Good afternoon and good evening, everyone. I'm Lakshmi Sudhan. I'm glad to have the opportunity to welcome all of you to the event, and I'm also thrilled to introduce the speakers today. Let me first give you a brief about SpaceNXT Lab to start with. SpaceNXT Lab was launched in Chennai, India as an industrial design and automation firm, especially in the field of aerospace and mechanical engineering, and later spread its wings in Sri Lanka in the year 2022. SpaceNXT provide industrial design automation solution as well as industrial education combined with internship opportunities for students. We currently have training programs on aircraft design using CAD, drone design, CubeSat design, electric vehicle design, and other industrial topics. Without further ado, let me introduce the panelists for today, starting with Mr. Sudhakar. Mr. Sudhakar holds a bachelor's degree in aeronautical engineering with specialization in rocket propulsion and orbital mechanics. He is currently working with ISRO as a propulsion engineer on R&D of rocket engines. He is an experimentalist with a combination of computational combustion. His areas of research include hybrid rockets, semi-cryogenics, modeling and combustion of solid propellants. He also delivers guest lectures in educational institutions to share his knowledge with the student community. Followed by our next speaker, Mr. Rifath Shaarook. Mr. Rifath is the Chief Technology Officer at Kidz India, who leads the development of indigenous CubeSat and pocket CubeSat subsystems. He has already launched more than 2 satellites into orbit, 3 payloads in suborbit. He has also been featured in Forbes magazine for creating one of the world's lightest satellite bus for student space research. Received multiple awards from state government for various innovative technology works, including IoT, robotics, etc. Our next speaker for the day is Mr. Gowri Shankar. Mr. Gowri Shankar is the founder of SpaceNXT Lab and co-founder of Deccan Asports and various other startups. He holds a bachelor's in mechanical engineering from KCG College of Technology, Anna University, and a postgraduate degree in aerospace system design from University of Bristol. He has trained over 1,000 professionals in the field of CAD, CAM, and CAE globally, and is also actively involved in social work in the field of education. He has also worked with Rolls-Royce PLC aircraft engines and Airbus projects in the past. He is a member of IEEE and a Smart City Council initiative and is also a guest speaker on multiple platforms. He has received various awards such as Bristol Plus Award, Bristol Council Alumni Award in Entrepreneurship, Distinguished Alumni Award from KCG, University of Bristol Highly Commended Alumni Award, etc. And finally, we have Mr. Hari Shankar. Mr. Hari Shankar built and shaped SpaceTug Private Limited, which has been his ardent desire when he was pursuing aerospace engineering. Space science has inspired him to go beyond the limits, be it in personal or professional life. He has always been keen to contribute to research and development while inculcating the same to the young minds. His knowledge about various domains can leave any of us in awe, but all we can see is his modest side. Mr. Hari has published research papers in various international and national journals like IJETAE, IJSCR, etc., and remains an important part of academia. He possesses a multidimensional and holistic approach towards work and people. In a nutshell, he is all about space science and imparting his knowledge to enthusiastic learners. Last but not the least, I would like to introduce the moderator for the day, Mr. Safar Rahman. Mr. Safar Rahman is the co-founder of SpaceNXT Labs, leading the industrial design aspect of the business, and has a background in mechanical and aerospace engineering from India and Europe, respectively. He has worked with clients such as Airbus, Molinary Rail, Siemens AG, Ashok Leyland, TAFE, TVS, Caterpillar, and many others. His specializations include CAD, drones, and industrial technology. Now, I would like to hand over the session to Mr. Safar for taking it forward from here. Thank you all.
Thank you, Lakshmi. That was a wonderful presentation and introduction of everyone. Without much further ado, let's go to Gowri Shankar and have his presentation. Gowri.
Right. Thank you, Safar. So thank you for the introduction, Lakshmi, and I think I'm glad to be part of this event today. So today we are going to discuss about a topic that is very close to my heart. I have not done a lot of preparation, but then we are going to discuss a lot more things today regarding IoT in space. 2 different fields coming together. IoT on one side, which is revolutionizing the way world works today, and space is something that we always feel distant towards. And how can these 2 things come together, right? So that is going to be the exciting part of today's discussion, and I'm happy to be sharing the keynote. So my contribution here is only going to be, briefly about what IoT is and what space is and how they can be linked together. But then we have a great set of speakers. We have Sudhakar from ISRO. We had Rifath, who is the person to have designed the lightest CubeSat in the world, and we also have Shankar from the startup end. So, which is going to be an exciting, kind of discussions for the day. So, let me share my screen. I have a small presentation on IoT in space, and then just go forward from there. Just give me a second. I'm going to share my screen. So we are going to discuss about IoT in space, and we are also going to focus on nanosatellites and CubeSats. I'll be representing SpaceNXT Labs today. SpaceNXT Labs, we have been working on different industrial fronts. We want to bring in space technology. We want to bring in, aeronautical engineering into different frontiers, which have not been, much exposed to these technologies at the moment, right? So we have participants today from India, Sri Lanka. We have from Indonesia. So it's glad to I'm glad to see that there are participants from all of the globe joining us. So let's look at space tech, right? So when we say space, it's basically there are a few things that comes to our mind. So let it be spacecrafts, or satellites, launch vehicles. So launch vehicles, we have been discussing a lot about launch vehicles in the recent past, with a lot of startups working on building launch vehicles. And the best part is building reusable launch vehicles, right? So this is again something new, although it has been there for so many years. There have been a lot of research happening on this. But then for us to come to a point where we can use such reusable launch vehicles, it has taken us so much time, right? So apart from that, space stations, we know about the concept of space stations and in-space propulsion, space communication, as well as new space, right? So this is again something that has come up now, a very modern term, new space, wherein there are entities, there are companies that are focusing on taking space tourism to the next level, right? So there's going to be a time when if you want to travel to Mars, or if you want to travel to moon, there will be a service provider for you to do that, right? So that's about new space, again, an exciting topic. So this is vastly about space, right? So these are the topics that will come to our mind when we talk about space, right? So let's see, since today's topic is IoT in space, so how are these things connected to IoT, right? So we need to know about IoT for that. So again, a very, very brief slide on IoT. I'm not going to go in depth because we have speakers today who are going to give us more details on how these technologies are linked together. IoT, right? So when you come across this term, most of you know it's Internet of Things, but what is it exactly, right? So if it all boils down to the kind of components, the architecture of IoT. So number one, in order to implement IoT, you need to have smart things, things that can listen, things that can sense, right? So that is why we call them as sensors. So any kind of IoT device needs to have some kind of a sensor, right? So it can be an image, it can be an audio sensor, it can be a light sensor. So all of these are sensors which are capable of grabbing information, right? So we have some smart things. Next, in order to remain connected to the cloud, right? So these devices that are collecting data, where are they going to store the data, right? So if it can be connected to the cloud, if it can be connected to the internet, there's a lot more scope for storing data, right? So that's why networks are very important. The second aspect of IoT. And then comes the middleware, right? So there needs to be some kind of a software that can basically interpret the data. It can give you something that is usable out of the data, right? So we have data and we have a capacity to store the data. Now, what are we going to do with the data? So there needs to be some kind of a middleware, something that tries to tell us what does this data mean, right? So, and finally, it boils down to the applications. Right, so we have seen so many different concepts around IoT. For example, smart homes and factories, drones, or wearable devices. Right, we use a lot of wearable devices nowadays, and we have a lot of data that we keep capturing continuously. Right, let it be your smartwatch or let it be your mobile phone. it keeps tracking data, right? So how many steps you have taken in a day, what is going to be your blood pressure, what is your eating pattern. So all this data can basically help you somewhere. It can allow you to lead a better lifestyle, right? So that's the whole point of technology. The point of technology is to make life easier, right? So we are going to take this to the next level using IoT, and then comes autonomous vehicles, right? So nowadays there's a lot of importance given to electric vehicle, and apart from that, we're looking at autonomous vehicles that can travel on its own, right? So driverless vehicles. So you just go and you get a Uber, let's say, and you just get seated. There's no driver. The car just drops you in the location where you want to go, right? So again, autonomous vehicles can be connected to this platform, and we have connected devices and traffic management. So these are all some examples of IoT that we can see around us, right? So although I have not told you, any technical detail or something that is too much of engineering, but I've just given you a gist about what this IoT comprises of, right? So we have sensors to get the data, and we have a network that can connect you to the cloud, or it can connect you to the storage that you need. And then we have a middleware, a software which can interpret the data. And finally, we have applications that can give some kind of usable data in a graphical format or in any other format that can be interpreted by day-to-day users, right? So that's pretty much about IoT. So I have told you about two exciting technologies, right? Space has always been exciting, something that we are always curious about. And IoT is a new technology that's going to revolutionize the way things work. We might have already started observing it around us, right? So how can these two be linked to each other? Let's see. IoT in space, just giving a perspective. The future of internet, right? So think about it, right? So we have different kind of internet connections. We had wired connections as well as wireless connections, and there are also satellite-based internet connections. Now, what is going to happen to this satellite-based internet connections with the advent of IoT is what we are going to look at next. So this is going to be the future of internet, especially when it comes to machine-to-machine communication, right? So if you take the wireless connectivity technologies that are available now, it started somewhere with infrared, and then we had Bluetooth. So infrared, if you remember, like maybe 10, 15, 20 years ago, any device that has a remote will have an infrared sensor. I remember looking at the sensor as a child, there'll be like a small bulb, like a LED or whatever you call it. And then it has to be very close to the device that you're operating, right? So the range of infrared used to be very, very limited. And then came Bluetooth, right? So with Bluetooth, we were, with the advent of mobile phones, transferring images, this, that, again, there needs to be a proximity, right? You can't send data via Bluetooth for long range distances. And then came Wi-Fi, right? So now we are connected over Wi-Fi. So let's say you have a drone, you're operating a drone. So nowadays you can connect it via internet, and you can operate it with your mobile phone. You just need a Wi-Fi that can connect the mobile phone and the drone so that there is a reasonable level of distance and range between the two devices. So now the requirement is that the range, there needs to be a larger range. At the same time, it needs to have a high capacity for downloading the data, right? There needs to be a high capacity for data. At the same time, there needs to be larger range available for operation, or longer range, I would say, right? So this has resulted in all the different changes in technology. So now it's going to be the revolution of 5G and 6G, right? So there's going to be high data capacity, right? So when we say 4th generation, 5th generation, 6th generation, it primarily has to do with the bandwidth as well as the kind of data these connections can handle, right? So I suppose in today's discussion, we'll definitely look into these topics. And low power, low range data transmission processing, low power and long range, right? That's what I'm talking about. So we need longer ranges, and we need a lot of data to be transmitted. At the same time, it has to utilize or it has to consume low power. So low power and long range transmission. So this is something that can be achieved with the advent of IoT, especially for space applications. Localization technologies, monitoring and asset tracking on ground and sea. So for this, we have been already using some kind of satellite technology for monitoring assets, especially on sea, right, more than ground, for any kind of tracking that happens on the waterbed. A lot of space applications have been used. And then comes another new concept of space, air, ground integration, right? So we have something happening in the space, we have something happening in the air domain, and we have something happening on the ground level, on Earth as well as on land as well as sea, right? So there is a need to integrate all of this together, right? SAG, space, air, and ground integration. Again, this is very important when it comes to bringing technologies and bringing different concepts together in the future. Again, IoT in space is going to play a vital role in integrating space, air, and ground entities, right? So, and then comes smart cities. We have been discussing about smart cities. So many events happening around this, and there have been so many governments who have already started working on smart cities, already building smart cities. So in order to track smart cities, right? So when I say smart cities, these are basically cities which can gather data and can change according to the available data. It's basically going to adapt to the available conditions by gathering data from here and there. So it's when you research into the smart city concept, there are so many things, right? Very, very small aspects, such as finding a space to park your vehicle, right? That's a very, it might appear to be a small problem, but it is not, right? Especially when countries which have high volume of vehicles and high volume of traffic, finding a space, the right space to park your vehicle. So this can easily be kind of facilitated through IoT sensors, right? So if you have a vehicle and you have a parking spot somewhere, so it keeps giving you information regarding how many spots are available based upon the sensors that are parked, or based upon the sensors that are already available in the parking space. This can be image sensors, it can be piezo or pressure sensors, light sensors. Any of this can gather this kind of data. So in smart cities, what happens is that the cities are connected with data and network, right? But these cities can also be studied from space, right? What is happening? What is the kind of motion that is happening around the city, vehicular movements especially, right? And maybe weather patterns and changes. So there's a lot of advantage for smart cities that can happen out of IoT for space, right? So these are a few things where IoT and space together can contribute towards technology that can integrate space, air, and ground, right? So that's just about what can happen with IoT in space. And then moving on to the education aspect, right? So most of you today might also be students who are learning something, who want to understand more about space or more about IoT in space. So what are the educational opportunities that are available around this area? So anyone who is interested in this area, you have a lot of opportunities, right? There are degree programs, undergraduate and postgraduate programs that allow you to learn about space or allow you to learn about IoT applications, right? Two different things at the moment, but there will be a point where everything is integrated, right? So you have avenues like you can learn about space propulsion. There are small programs around space propulsion. And today we have speakers from the space propulsion domain who can tell us, what are the avenues that are available around space propulsion as such. And then design of satellites. So at SpaceNXT, we have different programs, short duration programs, basically deals with design aspects of aerospace as well as space applications. So there are such institutes and there are such offerings for you if you wish to learn more on this topic. And space mission design, IoT related programs. So there are so many online programs that are that have been tailored around IoT. You can always go through those programs. A lot of information available online. And of course, engineering, as I told you, aerospace, it can be aeronautics as well as astronautics, whatever you are interested in. There are a lot of educational opportunities that are available there. I just added this slide just for those who want to know what can you do after this, right? So you're interested in the field, but then how do you take this forward, right? So that's the purpose here. And then coming to the a bit more in-depth scope of IoT in space. So this is more relevant to what's happening in space, right? So in the previous slides, I might have told you what is the importance of integrating space and ground, how on Earth can space help us, especially with IoT, right? So these are the things that we were discussing. But then in this slide, you can see what are the applications of IoT exclusively in space, right? So connected space vehicles. So there are space vehicles. So I think we will definitely have some discussions about this where you will get to know more. So when I say mission-to-mission communication, so that is directly applicable for connected space vehicles. And nowadays, people are also researching on new concepts such as Internet for Space Things, IOST, right? So the objects in space can be connected. That's the idea behind it. We'll discuss more about this. Space robots, wearables in space, smart construction in space. So if we are going to colonize different planets in the future, how are we going to create architectures? How are we going to proceed with the construction work over there? So those things can also be facilitated through IoT. Space debris management, traffic management. So traffic management continues to be a very important and vital role, especially when it comes to IoT in space, right? So I think there are a lot of challenges. I have just shown you a lot of optimism around this area, but then there are a lot of challenges, especially let's take space debris, right? So space debris is an important issue to be resolved. There are more and more CubeSats and Nanosats that are being launched into lower Earth orbit maybe, and what are we going to do with the debris, right? So these spacecrafts, these satellites remain for a very short period of time. The operational duration is very short. So what will happen to them eventually, right? So we need to know about that. But luckily, there is always a solution for a problem, right? So technology will always find a solution for a problem. So let's see what can happen to this space debris issue. Through the discussion today, we will definitely get to know about the drawbacks, the negative aspects, as well as the positive aspects about this particular topic, right? So I think that is pretty much from my end. I just wanted to give you an idea about what we are going to discuss today. And for those who want to pursue further things or further education in this topic, you definitely have a lot of avenues, right? So I just wanted to put that in as well. So I think that is pretty much from my end. Safar, over to you.
Fantastic, Gowri Shankar. Thank you for that insight. I wonder if we can use Apple Watch in space. Maybe not. So again, like Gowri Shankar said, those who want to check out on the design courses, you can always visit our website at SpaceNXTlabs.com, or if in any industries want to collaborate with us, you can contact us at contact@SpaceNXTlabs.com. So I see someone raising a hand in the for questions. The questions will be put in the end. So people who have questions or who wants to ask questions can put their questions in the chat box so that I can ask them, or if you want to ask them yourself, you can do it in the end. Thank you. Okay, next we shall go ahead with Sudhakar. Sudhakar, the floor is yours.
Yes, thanks for the introduction, Lakshmi ma'am, and SpaceNXT Labs and Gowri Shankar for giving me this wonderful opportunity to interact with the student community. Just a second, I will share my presentation. Is my screen visible?
Yes, Sudhakar, you can.
Yeah. Good evening, everyone. Myself, Sudhakar, and I'm here to give a small talk on Internet of Things in Space and their associated opportunities and challenges. Okay. Before starting, we can ask this question to ourselves: Are we currently in a space race or race to space? Well, to answer this, it all started as a space race, and over the past 2 decades, it has become a race to space. As humans, we are always being fascinated about space and highly curious about exploring what's beyond Earth for centuries, right? So, with the tremendously developing science and technologies, we are able to reach space and exploring space with the aid of rockets and satellites using computing and communication facilities. Looking at IoT, the future of space exploration will involve new information communication technologies, that is IoT, and these connectivity technologies are drastically combined with artificial intelligence and machine learning. The most recent development, that is the 5G and 6G mobile networking technologies. These utilize the space, air, and ground integrated network called SAGIN. Some of the research areas of IoT include, as Mr. Gowri Shankar said, engineering the future internet, involving 5G and 6G mobile technologies, where we need a greater reliability for M2M communications. And IoT infrastructure comprises of sensors, sensor networks, and actuators, and we need data processing and management systems. And the hardware technologies for low power consumption and long range data transmission and processing. And we also need localization technologies for humans, robots, and things, including satellite based methods and middleware platforms for IoT applications. IoT standards and semantic technologies. Some socio-technological issues of security, privacy, and ethics in relation to the deployment and use for business IoT devices and services. Now, what you are looking at is a typical IoT ecosystem. If you see the bottommost part, that is a sea network, which consists of ships, submarines, and underwater sensors. After that, we have the ground network, which has satellite terminals and ground stations, along with computing devices, sensor networks, and connectivity towers. We also have an aerial network between ground and space, which is at an altitude of less than 50 kilometers from the Earth. And here we can make use of the unmanned aerial vehicles and balloons, that is hot air balloons. And looking at the space segment, we have two different kinds of orbits. And we have a geosynchronous orbits or the Earth synchronous orbits, which is typically 36,000 kilometers away from the Earth. And non-geo orbits are 200 to 25,000 kilometers in altitude from the Earth, and it comprises of satellites and space telescopes, including the International Space Station. And we also have an interplanetary network where there can be orbiters around other planets, and even landers and rovers. So we need some requirements for IoT based on satellites, right? Looking at this, mostly non-geo satellites are better suited for IoT applications, since the propagation and delays are less compared to the geo orbits. And also we need a constellation of satellites for continuous coverage. If we have a look at the visibility of low and medium Earth orbits, it's 20 minutes and 2 to 6 hours respectively. And we need more sophisticated equipments to compensate for the Doppler shift, and enabling communication with moving satellites is a challenging task. And we need satellite handovers without any lags. And some of the applications of low and medium Earth orbits are Earth observation, geolocation services, and machine-to-machine communications. Now coming to satellite communication IoT applications, here the end devices, sensors, and controllers are spread over a wide geographical area, as we have infrastructure constraints in the terrestrial and aerial networks. Example, in the case of marine and air transport. And there are IoT applications are bound by delay requirements, which can be delay sensitive systems. These delay sensitive systems can operate with a tolerable delay. That is, the delay won't affect the performance of your mission. Typical examples include water monitoring, shipping access tracking, and environmental monitoring. And delay sensitive requirements, there is a very stringent time delay requirements, and it is very essential for optimal performance of the mission. So these are typically used in the case of defense applications, autonomous and vehicles, and industrial automation. In the case of a defense application, if an enemy aircraft has intruded into your territory, you have a very short time to respond, which is called the response time. In that case, we need not have delays. We have to respond immediately. So in that case, we need delay sensitive systems. And satellite and terrestrial networks integrated with IoT. These IoT sensors in the land or in the aerial network produce data traffic, and which when combined with satellites leads to expensive signaling over the satellite link. So we need optimization protocols to reduce the traffic over satellite return, and also to improve the quality of service. Satellite based 5G and beyond. The most recent development in mobile technology is the 5G, which promises us with higher bandwidth, lower latency, and higher reliability for time and mission critical applications. Here, in the case of satellite based IoT, we require full integration of the ground, air, and satellite communication networks. While the mobile network service providers have already started deploying 5G, and the manufacturers are launching 5G devices, industry and academy have already started developing 6G, which is expected to be standardized and deployed in the coming decade. And 6G can provide data rates exceeding 1 terabytes per second. This can be combined with sub-millisecond ultra-low latency over unubiquitous 3D coverage areas. Here we have the ground and aerial networks used in conjunction with the satellite network for key performance. So these satellite communications can use low Earth orbit satellites and CubeSats to complement for the network coverage. So UAVs also play a major role in the case of aerial IoT network. As UAVs are becoming more popular, these can be equipped with communication and IoT sensor devices, and they can provide data services like data collection, target identification, and even temporary communication for the purpose of military. And these UAVs can be easily deployed and managed with a wide range of applications, and at a cost which is effective. And coming to the CubeSats, these are a new class of miniaturized satellites which emerged as a viable solution towards establishing global connectivity at low cost. These CubeSats can typically support multiband, milliwave, microwave, and terahertz band frequencies. And CubeSat based IoT and broadband solutions are becoming more popular. And some of the examples include the Iridium Next, Astrocast, and SensorPod. And as I said, we need an integration of space, air, and ground integrated network. This satellite network can provide a wide area coverage, including the oceans and mountains. The air network increases the capacity in areas with high service demand, And the ground segment is densely deployed, and it can support very high data rates. So we need a space, air, and ground integrated IoT network paradigm, which can be formed by integrating satellite and air communications along with 5G and IoT technologies. Each nodes in the network, they closely cooperate and coordinate to transmit messages efficiently. So this is typically utilized in the development of smart cities. And they can also support vertical markets with different requirements as well, which can be automotive, environmental protection, medical, or search and rescue. And these networks need to be flexible, manageable, scalable, and customizable to support multi-service demands. And we need to model a 3D channel to achieve this. Now, let's have a look at the emerging developments and the challenges associated with them. So, in the case of smart architecture and construction in space, construction of smart buildings is indeed a very interesting research area with its unique design and developmental challenges. In the case of small-scale activities, robots and self-assembling structures can be utilized. But when the structures are large, this is a bit difficult to execute. And as human activities and operations extend to space, there is an increasing need for computing and storage resources in space. So we need data centers and management services. Communication through satellites is feasible, but there are issues bound by latency, delay, and transmission issues over the nodes. And we need effective cooling and protection of the servers operating in the space environment, which is a complex task. The good sign here is several startup companies are working on establishing micro data centers in space. Space robotics. So apart from assembling parts in space, full-fledged robots can help humans in space station. Japan developed its first robot astronaut, Kirobo, and it was demonstrated in the International Space Station way back in 2013. And this was used in a way to entertain the astronauts on board. And there is also NASA's cube-shaped Astrobee robots. They help the astronauts in their daily routines, maybe moving cargo, documenting and sensing experiments, or carrying out repair and maintenance. These robots can be used as swarms and could be deployed in space stations and space vehicles to assist the humans. And if we see the technical challenges associated with space robotics, manipulation of objects in zero or near zero gravity and mobility through the planetary environments is a difficult task. And we need advanced sensing, perception, and mechanical agility, along with effective teleportation and human-robot interactions. Connected automated space vehicles. As we all know, reusable space vehicles can transport humans and materials to space and return back to Earth. This enables space tourism. And in future, we can have automated space vehicles for transport between various space stations. Again, the flip side here is traffic management in space and collision against debris. Licensing and identification of the vehicles is also a difficult task. And network to wearables and apps in space. As we all know, NASA also develops spacesuits for their astronauts. And these spacesuits have a built-in health monitoring systems for measurement of temperature, pressure, and humidity, kind of biological sensors. Some of the most recent works include garment integrated variables with biosensors, and even textiles with sewn-in electrodes for heart rate monitoring and biological clock monitoring. So coming to space situational awareness, As we all know, we have thousands and thousands of satellites which are currently operational and non-operational, and their paths and other debris floating around the space. Space debris imposes a huge threat on the future of satellites and vehicles in space. So to manage this, we need massive support from various parties to ensure the safety of space travel and satellite launches. Machine learning technologies will be very helpful to improve the orbital predictions, and we can build physical models where the data is insufficient. IBM is carrying out a space situational awareness project in the low Earth orbit. So in the future, there will be many such companies who would be coming up with projects like this. And here the challenge is detecting and tracking of the space debris due to the huge volume is a complex task. Now, coming to colonizing planets, we have already started looking beyond Earth for planets which are habitable for humans. So our first target is the Mars, where we already have the Curiosity rover and even our mission to Mars orbiter mission. So to colonize planets, we need infrastructure development, which requires sensor networks, data navigation, and communication technologies for human livings. In the case of rovers, we need rovers with computer vision techniques and image comparisons with its set of sensors to keep movement of the vehicles in planetary surfaces. And here we need very robust inertial navigation systems with highly accurate accelerometers, gyroscopes, wheel odometers, and other instruments. So far, we have seen some of the recent developments and their associated challenges. And there is a silver lining to these. That is, with the emergence of rapid technological advancements in IoT, powered by artificial intelligence and machine learning, the opportunities for space exploration has enabled and it's expanding. So over time, as these systems mature, we can say that it is increasingly evident, and IoT can be seamlessly integrated with space-based technologies for future space exploration. Space tourism and Mars travel were once futuristic, and we are already reached there now. Our takeaway here is, as communications and computing technologies are becoming more pervasive, we need to build foundation on the knowledge of automation and ubiquitous connectivity, which would be very essential for the future of space travel. So having all these, the future of space travel and exploration will be great and promising. And we all have an exciting career ahead in the future space. So I would like to conclude my talk with this few lines. What I would say is, ignite yourselves, propel hard through the hustles, thrust in the right direction, follow your designated trajectory, reach your intended orbits, and accomplish your missions successfully. Thank you.
Thank you, Sudhakar. That was a wonderful talk, especially so much enlightening regarding the IoT in a space application. Especially, I was very curious about the space architecture and the scope of space architecture and network wearables. Hopefully, soon we'll be seeing companies in those sectors. All right, we'll move on to Rifath Shaarook next. We'll be playing a video.
Hi everyone, good evening. This is Rifath here. So let's have a look at our journey video about what all the missions we have did in the past, and then I will continue the session. Please go ahead and let's play the video. Thank you. Thank you so much. Hello, everyone. Good evening. This is Rifath here. I'm the Chief Technology Officer and Lead Scientist of Kidz India. First, I'll give you a small overview about us, and then we will get into the topic of IoT in space. So we are an aerospace organization primarily working in development of cube satellites and pico satellites. And we are also developing sounding rockets. We started back in 2010 as ambassador for NASA. We have trained more than 5,000 students in Kennedy Space Center. And so far we have launched, we are the only Indian organization to launch 18 balloon satellites, 3 suborbital payloads, and 2 orbital satellites. All these are launched for various purposes. Each mission was having different purposes, but this is our total mission count. And we are in process of launching another 2 satellites, and one of the satellites is scheduled for launch in next few months. And it is going to be one of the biggest satellite, weighing around 12 kg. So we are in progress. We are working on that. So let's get to the topic of IoT in space, which is one of my favorite topics, because both the satellites, orbital satellites we launched, were actually IoT satellites. In fact, the Satish Dhawan satellite we launched last year on board PSLV C51 was a LoRa IoT satellite. It was a dedicated satellite for demonstrating IoT capabilities in space, and it was successful. Worldwide, we have demonstrated how we have developed the capability of indigenously designing and manufacturing IoT satellites here in India. For example, the entire system of the satellite, like the solar panels, onboard computer, communication system, almost 95% of the parts were indigenously designed by our organization and manufactured locally here in Chennai, India. So we got a full indigenous system for developing IoT satellite, and we have developed the capability of deploying our IoT constellation. And parallelly, we also work with a lot of other industrial projects, IoT and automation projects. So combining IoT and space is a very favorite topic for me. I'd just give you a clarity of what are the different things in IoT, so you can have a better clarity of what is happening. And I would also like to let you know the difficulties in IoT in space and what are the problems we might be facing in the future. First of all, the IoT, Internet of Things. What is Internet of Things? We know what is Internet, right? When computers are connected together, which can talk to each other, it's called Internet. Usually in Internet, humans, we sit at the computer or mobile and we browse through the computer. So Internet of Things started when things like a fan, a washing machine, or a air conditioner can communicate with Internet. For example, if you can turn your AC from your mobile phone using Internet, or like turning on your lights and everything. So this is how Internet of Things got started. But IoT is different. Internet of Space Things is different. It is about controlling things in space. For example, like previously Mr. Gowri Shankar said, like having wearable devices or having interconnected spacecraft. So those things comes under IoT, Internet of Space Things. But while commonly talking about IoT in space, the industry right now, at least like what is happening right now, it is about providing IoT connectivity and M2M communications to the assets, ground assets, like sensors or nodes, via satellite, delivering it via satellite. For example, we have companies like Swarm Technologies, which was recently acquired by SpaceX. We have Lucana Space, we have Globestar, Iridium. So these companies, they provide IoT connection. For example, there is also a difference between Internet satellites and Internet of Things satellite network. In Internet satellite, for example, what Starlink is trying to do or Amazon Kuiper is trying to do, they are trying to provide full-blown, full-fledged Internet to the users on the ground. The speeds will be somewhere like 300, 400 Mbps. So you can download, things, you can have video conference, you can do gaming, a lot of other things, full-fledged internet connection you can do. But while talking about Internet of Things, it is always about low bandwidth, low speed, simple communication. For example, most of the times in Internet of Things, you are just sending JSON packets, whether what is the output from sensor or what is the command you need to give to the mission. So most of the times in Internet of Things, the bandwidth required, the data rate required is very less. So in Internet of Things, the communication you need to provide via satellite is much less advanced comparing to what Starlink and Amazon Kuiper is trying to do. So that is why one side internet, satellite internet, space-based internet is going, on another side satellite-based Internet of Things is growing. Because for example, where do you think we would need IoT in space? For example, see, we have smart cities, we have smart homes and all these things. But I would personally think space-based IoT would play zero role in smart cities or like smart homes kind of things, because space-based Internet of Things is very expensive. For example, if you want to turn on a light or turn off a light, or if you want to send some data, usually that is what happens in smart cities and smart homes, smart factories, or like connected vehicles, or in urban areas. You will be sharing a lot of packets. Basically, it may cost like less than 50 paise to send one packet, or 1 rupee to send one packet. But let's compare the prices which Swarm Technologies right now providing, which is a part of SpaceX. To send one packet, it may cost you somewhere like 25 rupees, 30 rupees, like that. Few MB of data for Internet of Things based satellite service is around like $50, $100, like that. It's very expensive comparing to traditional IoT using terrestrial communication. For example, we are having GPS, we are having broadband, Wi-Fi, all those things on the ground, right? So most of the Internet of Things which right now we are experiencing are based on this terrestrial internet connection, not based on space-based IoT things. So terrestrial-based things are very economical, so you can abundantly use it and do a lot of crazy things. But space-based IoT is only used, or can be only used, in mission-critical applications. We call it as mission-critical applications. For example, if you're having a tsunami buoy, ocean buoy, right? Those are sensors which you deploy in middle of the oceans to study the ocean parameters, maybe detect tsunamis, like that. So to send those data to ground with the highest possible speed and without much latency, in those scenarios you can use space-based IoT. Or if you want to detect forest fire, you are having a fire sensor inside a forest where there is no traditional mobile communication or traditional internet is not available. So you can use space-based communication system for sending this data. Same with, for example, Amazon Kuiper or SpaceX, Starlink as well. SpaceX Starlink doesn't have any scope in urban areas, because urban areas are already having a very good population density, and they are having already good terrestrial internet available, so they can just make use of it. They can be only used in remote areas where people need proper internet connection. Same thing applies for IoT, like space-based IoT as well. In urban areas, in cities where the most smart cities will be coming, there will be already good internet connection available, so people can just use that. The IoT from space would be mostly used only in mission critical applications, maybe like in defense, where they are in border and they want to send some data, like mission to mission data, or like when they are in poles, or some kind of research in ocean, and mainly in ocean trade, tracking container ships, tracking submarines, tracking ocean assets, or maybe assets in deserts, in these kind of areas where the traditional internet is not available, at the same time, you don't need much of bandwidth, a very little bandwidth is enough. That is where most of the time you can go and study the case studies which already the Swarm internet, they have published, and there are a lot of research papers already published about the scope of Internet of Things from space. So this is very limited. The customers are very limited, even though the technology is very unique and the technology is very great. The potential customers are very limited if you are just comparing traditional IoT from space. As I said, IoT, smart cities and space colonies are totally different things, which I'm not planning to cover today. I'm just talking about as the topic IoT in space and what the traditional already we're talking traditional, even though it's just few years, because technology is progressing so fast nowadays. So I'm talking about that only. So it's very limited, but there is a huge surge in companies which is providing IoT connectivity from space. The reason is building an IoT satellite is the easiest type of satellite you can build. I'm not kidding, because we have built a lot of different types of satellites, including IoT satellites as well. Building a satellite which can provide IoT services. See, while talking about IoT from space, we cannot avoid, we cannot, go without mentioning LoRa. You might have already heard about the LoRa technology, which is a proprietary modulation technology developed by SpaceTug Corporation. Actually, not by SpaceTug Corporation. It was developed by a different corporation, but right now acquired by SpaceTug. It has very good long-range communication at very low power. That is what enabling this entire IoT revolution in space. Their transmitters and receivers. Transceivers are very small with inbuilt modem. Usually for satellites, we have to develop a separate modem. We have to work on link budget, a lot of other things, very technical thing. But this one technology, LoRa technology, has completely revolutionized the way we communicate with satellites and balloon sats in the last year. For example, 5 years ago, we used to carry big antennas, antenna rotators and everything to communicate with our satellites and balloon sat. But our recent SDSat we launched, it was having a LoRa transponder on board, an IoT transponder. And we were able to communicate with the satellite using just a single wire, not any fancy antenna. Just in FM radio or not, we have aerial, right? So that kind of single antenna attached to a car, it was able to communicate with a satellite which is traveling at a velocity of 7.8 kilometers per second at an altitude of around 500 kilometers. The reason is it has a very good link budget. It gets complicated when we start talking about link budget, receiver sensitivity, noise floor and everything. But the LoRa technology has made the link budget very efficient. That nowadays, in smaller satellites, the amount of power, electricity we can generate is very less. So the transmitter power is also very less. So we need efficient transmitters. This LoRa technology has, solved the problem so that you can easily communicate with ground system. I think LoRa is the single most technology which has started this entire, IoT revolution in space. If we say that it's not a, a big thing, like it's very true. So what is happening is right now, if you are developing, let's say, a hyperspectral satellite or an Earth observation satellite, or if you want to provide internet from space, you need to have a system called attitude determination and control subsystem, because most of the time you want your camera to be pointed towards the Earth because you want to capture the photos of Earth. Or you might be using S-band or Ka band, Ku band communication for communicating with ground, because you need very high speed data rate. For example, like 200 Mbps, 300 Mbps, like in case of Starlink, or at least like few Mbps of data. So you need this attitude control subsystem, which is the most expensive system in a cube satellite. The system alone can easily cost you more than hundreds of thousands of dollars. But for building IoT satellites, most of the time you don't need an attitude control system, because the satellites, if you go and look at these satellites, IoT satellites, these satellites operate under VHF and UHF band, which is around 140 megahertz and 430 to 440 megahertz. We call these frequencies as omnidirectional frequencies or omnidirectional, bands. The frequency, the wavelength of the frequency is so big that you don't need to point your antenna towards the Earth. Even if the antenna is facing in the opposite direction of the Earth, you'll be still able to get the data on the ground. So this system eliminates the requirement of ADCS, and it also, the link budget, the efficient link budget of the satellite reduces the power needed for developing the satellite. So this entire possible things technically makes the satellite very less complicated. It's very less complicated, and satellites are very small. For example, if you go and look at Swarm satellite, their satellites are 0.25 U, which is 10 into 10 into 2.5 centimeter. For example, to compare it with the size, it's as big as a thick slice of a bread. Just as big as a thick slice of bread. It is that small. And now we are having Lucana Space, and there is a FOSA system. They are coming. Their satellites are 5 into 5 into 10 centimeters. This entire thing is making the satellites to be very less complicated. So every new space company, most of the companies which are coming into space industry, they want to get into space industry. Technically, it is a good thing. More companies can come, more companies can, play into this. But if we are talking business-wise, at the end of the day, if you are doing something in space and investing crores of, dollars, millions of dollars, when the industry is easily, interruptible, like anybody can easily come and start something. Business-wise, it's complicated. Investors will not have confidence to put so much money because it is highly competitive market. It's not highly competitive, it is easy to compete market. So that is one of the major disadvantage of, the traditional IoT in space. But only the technology part is actually very easy. But there are two other major challenges. I think one can be solved with SpaceTug, maybe in the future. The first part is having a constellation, right? We already have 2 satellites in space, but that is not enough for us to start commercially providing the service. We can just demonstrate, we can test out things, but we need at least 50 to 60 satellites in orbit, evenly placed out in different orbits to provide communication flawlessly and hand over from one node to another node. For that, you need to design orbit. But the problem is, since these satellites are so small, the entire 60 to 70 satellite itself will weigh, less than 250 kg, the entire satellite. But the problem is you cannot launch all these satellites in a single rocket. It has to be launched during different times from different, inclination, different altitude. So catering the launches are very hard. Getting the launch contracts are very hard because you have to launch like 10 satellites at a time, 20 satellites at a time. So you can reach different orbits. So finding the launch provider and getting a good deal for the launch is very hard. In space industry, usually the bigger the satellite, economical it is. It may sound opposite to you because you may think the smaller the satellite, economical it is to launch. But the problem is, if the satellite is just 1 kg, it will cost you around $100,000. But if the satellite is 100 kg, just the 1 kg will just cost you around, $5,000. You can go and check the pricing in SpaceX website. The heavier the satellite you get, price per kg will get decreased. But since IoT satellites are so small, each satellite will be weighing just 250 grams. The launch is expensive, it's huge. Even though you're saving a lot of cost in building the satellite, you will be, wasting all those costs while launching it. That is why companies like Momentus, SpaceTug, we have a few other companies, they are coming up with SpaceTug, SpaceVan, all these new technologies where they can carry hundreds of these small satellites and put it in different orbits. Maybe if that technology becomes a viable solution and economical, this problem might get solved. The biggest problem is legal issues. Since you are an IoT satellite provider, it's all about radio communications. You need to get radio licenses from each country. Whatever the countries you are going to operate, you have to get licenses from each country. For example, right now SpaceX is struggling to get license for operations in India. But the problem is the business potential in IoT is right now, at least for next 1 decade, is going to be small. You're not going to put like billions of dollars in these companies. So right now, the bigger companies like Amazon, Paper, and SpaceX itself is struggling to get licenses. But even though your satellite is small and your investment is small, but the legal process is same as what SpaceX and Amazon is experiencing. Their satellites are big and providing faster internet, but the legal process is same. Yours is a smaller satellite and lower bandwidth, but still you have to go through all the same processes. So the revenue to the amount, the ratio between the revenue to the amount you are spending for the legal fee is going to be very high comparing to the bigger satellites. That is also one of the major advantage right now. That is why even though many companies are easily penetratable by using technology, it's easy, but launch and legality is very complex. That is why even those at Space Kidz India, we have full-fledged technology capable of deploying around 100 satellites in space, IoT satellites, because we have developed transponders, we have developed ground infrastructure and everything. But still, these other problems are always a bottleneck for these systems. For example, in India, we still don't have a clear space policy. So if you are planning to launch a satellite communication company in India, you are going to wait a long time to get the license itself, even though you are technically capable. So these are some things. More than technology right now, I think there is a huge concentration we need to put in space policy, creating space policy so that these new companies can easily get required licenses. At the same time, make it easier for smaller satellites, because smaller satellites with smaller investments, these companies cannot spend as much as bigger companies are spending for legal fees. So the government has to make the process easier so the smaller new space companies can easily get started with these technologies. And launch is also another problem. So these two are the these are the few points which is going to define the IoT in space. But if you are talking about 5G from space, 6G in space, and space-based internet and everything for other planets, that is going to be very complicated, and that would require a separate discussion panel to discuss about things, because those are very well separated from the discussion we are doing now. So these are the few pointers I wanted to talk, and I hope it would be useful for you guys. Thank you so much for the opportunity.
Fantastic, Rifath, fantastic. And you've touched a lot of aspects, in fact, in IoT, as well as space, as well as business side of things, and all this without any presentation whatsoever. It was wonderful, and all the best for SpaceKid's next launch.
Thank
right.
you.
To all the attendees, those who are interested in CubeSat design courses and other drone design courses, you can always visit SpaceNXTlabs.com, and you can leave your doubts and queries there. Over to our next speaker, Shankar. Shankar, the floor is yours.
Hello.
Yeah.
So sorry for the things. I think already we are running out of the time, so I'll try to complete as fast as possible.
Take your time.
Yeah, sure. So hi everyone, I'm Shankar, the founder and CEO of SpaceTug. So I think all my colleagues like Gowri, Shankar, Sudhakar, and Rifath, they've talked more about IoT in space. So let me talk few basics. So what is satellite? Kind of things, and what are we going to do in the upcoming days? So actually, SpaceTug, we work on a vision to make a space sustainable. So we are building a micro satellite to remove the space debris. So I'll come to the thing called space debris in the in the last parts. So the first thing is like, so what the space starts. So we all say the space starts from mesosphere, exosphere, all those things. Okay, so I don't want those kind of things. So let me see clearly. The space starts from 100 kilometers. If someone asks you where the space is from, okay, so say them the space starts from 100 kilometer. We call it as Kalman line, because I used to take classes. Okay, so people used to say like space starts from 1,000 kilometers, 500 kilometers. So let's make it clear. If someone asks where the space starts, so say them like space starts from 100 kilometers from the Kalman line. Okay, so we call it as Kalman line. For the satellite, so we all say, okay, satellite is something, okay, we use it for the telecommunication, weather forecasting, but the basic definition is when a small object is running around a bigger object, it's called as a satellite. Okay, for example, sun and earth is, okay, so Earth is the center of the sun. So next, we launched the first satellite called Sputnik in 1957. Next, the Echo satellite by US, TEOS, and Landsats. So can I see satellite pass, okay, in the sky? Yeah, of course you can see. So after sunset and before sunrise, you can see a star moving in the sky. Okay, so there's something about the satellite moving off. So how can you see those satellites? So just download a software called as ISS Tracker, which will help you to find the satellites passing above your locations. So the main thing, okay, as I said, something called space debris. So from 1957 till today, we have launched more than 6K rockets. Among, okay, with those rockets, we have launched more than 13,000 satellites. Among them, only 5.6K are the working satellites. So remaining are called as space debris. Okay, so space debris is nothing but the dead satellites and leftover rocket bodies. So this can make a big collision. Okay, so when building a satellite, put up a backup plan. Okay, the backup plan is nothing but how to bring it back after after it works in the space. So there's a law that you should bring a satellite within 25 years back to the Earth. So when building a satellite, try to put up a re-entry plan, whether you're going to use a dark sail or any other thing to bring it back to the Earth. But debris, okay, so the radars in the Earth are tracking close to 31,000 objects in space. Okay, among 31,000, only 5.6K are the working satellites. So just imagine the remaining count. So 80% of the objects are non-functional. So when building a satellite, make a backup plan how to re-enter the satellite once the work is done. Because okay, so you can take Starlink. So Starlink, okay, Starlink company and OneWeb, while launching itself, they put up re-entry planning. So once this work is done, they try to re-enter the satellite within like 6 months of timing. So make a plan of those things. Thank you.
All right, Shankar, and it's great what SpaceTug is doing. I think nobody has entered into that venture. It was a great startup player. Hopefully, we'll be able to reduce all the space debris as early as possible. Right, we'll move on to the questions now. I think I'll post a question that was posted in the chat section and to the panelists. What are the techniques small companies can use in order to perform quality testing when they build a satellite?
I think I can go ahead and answer.
Yeah.
Because we have did that recently for one of our recent satellites. Testing a CubeSat is a bit different from traditional bigger satellites because mainly the size. For example, the entire size of the satellite itself is smaller than a single component on a bigger satellite. So, but basically the primary testing we need to go through is called launch environment testing. because during the launch, the satellite will go through very huge amount of vibration and G-shock. The shock can go maybe sometimes up to 6G. I mean, the shock can go up to 100 G, for example, in case of PSLV, and loads can go up to 6 to 7 G sometimes. So depending upon the launch vehicle, the launch service provider will give you a profile for doing vibration testing, vibration testing, and shock testing. And then to make sure that your satellite can work in space, in the vacuum and in the coldness and the heat of the space, because in lower Earth orbit, your satellite will be in the temperature of around -70 to 80 for 45 minutes. And for the next 45 minutes, it will be experiencing somewhere around 70 to 80 degrees. So to make sure your satellite can handle this, rapidly changing environment in vacuum, you need to go through a test called thermovacuum testing. So these three are the major testing we do before launch for a satellite. This is for the entire satellite. But apart from that, there are other testing, system level testing you need to do to make sure your transmitter works, your onboard computer works, the thermal system works, and everything. So for that, we have set of simulations we do. For example, softwares like ANSYS and everything. Before doing the test itself, we do a lot of simulations. At the same time, we have laboratories available for doing RF testing. For example, we have to, if you're launching from SpaceX and few other things, the MEMC regulations, which is electromagnetic interference and electromagnetic compatibility testings are a must. So, for example, we have our own, spectrum analyzer and testing equipment in our lab. So where we can do our own testing, or there are labs available externally where you can go and do the test. So these are some of the tests we need to do for launching, as well as internal quality assessment. You have to come up with your own quality policy, and this quality policy has to be submitted. For example, if you're launching on PSLV, there will be something called mission readiness review, or MRR, where the team will go through your quality policy to make sure that you have followed all the standards. And the component, for example, even the PCB has to follow some standard to make sure there is something called outgassing. When you're in vacuum, outgassing will happen, which can damage other satellites which are nearby you. So they have to make sure that the components you are used in your satellites are up to the standards created by both, open regulations are available. There is something called NASA Material Selection Guide, and ISRO is also having similar guide, which you can request them and get it. So they will also go through all this test to make sure, and to certify your satellite as flight worthy. So these are some things we need to do. It's right. Really a tiring process, but you have to go through.
The same person had the another question. I think you've answered it in the end. He was asking about what are the regulations that we need to go through.
Regulation is another major headache because the major regulation you have to go through is called frequency coordination. For example, like how we are having Suryan FM is at 93.5 megahertz, some other FM radio is at a different station. If these two stations are operating at the same frequency, you won't be able to hear either of them. It will be just noise. So same thing goes for the satellites. Two satellites operating nearby should not have similar frequency. Otherwise, none of them can download the data. So you have to go through a process called frequency coordination, which is done by ITU, International Telecommunication Union, which is part of United Nations. It is such a tiring process. The process itself can take like 1 year to 2 years. And even before starting the development of satellite, you have to go through this. There are so many other, if you're launching from US, there is something called ODER, Orbital Debris Assessment Review. You have to go through that. So depending upon the launch country, there are tens of different regulations. But this ITU process is most toughest and applies to all the countries in the world.
Great, great. Anyone else wants to ask questions can raise their hands.
Right. Also, I want to add one thing. So for example, if you are launching a pico satellite like 250 grams or 500 grams satellite from US, sometimes the regulatory cost can be more expensive than building and launching the satellite. Sometimes it happens like that.
Right.
It's very expensive.
There's one general question which I think is applicable to any of you. Well, like, what are the challenges of IoT in space? I mean, is it safe from cyber threats, for example, or even physical damage for that matter? How do we tackle these issues in general?
Right. So I will. I'll just give a perspective to it, although I might not be, be able to answer it holistically. So I think Rifath's discussion had a lot of pointers to what are the negative aspects of IoT in space, and he could carefully tell us, draw a line between where we can utilize them and where we actually cannot, right? So depending upon the legalities, the cost involved, right? So these are the facts. And apart from that, if you look at the operations, so are we going to operate in regions where there are like scarcity of population, or are we going to operate with a high dense population, right? So that's an important decision maker, especially when we're talking about satellite-based internet and things like that. So I think today's discussion, we had a lot of points regarding the negative aspects, space debris being one more important aspect, right? So that's something that we have to get rid of, right? So I think if any of you have anything else to add to that, then it's over to you. But then we pretty much had a useful discussion regarding the positives as well as the negative aspects.
One thing I would like to add is regarding the cybersecurity, which is a great question. For example, there is a cybersecurity firm called WiseKey in UK, which is right now planning to develop a safe, a safe solution for IoT satellites. But generally, space communication itself is very prone to cybersecurity problems, because when you're in a line like a optical fiber or something, it's different. But the moment you are using radio, your packets are in air, and anyone with a suitable receiver can receive it, even though if they are not able to decrypt it. So it's a very big solution. And another problem we have is something called packet collision. That happens when too many nodes on the ground are trying to send data at the same time to the satellite. So right now there is a huge demand for not just space engineers and aerospace, scientists, but all the satellite companies are also hiring cybersecurity people. So if you are a cybersecurity people and you want to be in cybersecurity industry, the space industry is having a huge demand, not only for the space side, but also for deploying ground infrastructure, because we have to make sure the ground infrastructure is also safe. So yeah, that is a good question, and there is a huge scope for cybersecurity people in space industry.
Okay, I have a controversial question to ask for all the space companies or space enthusiasts. I mean, we all know the benefits of rockets and space technology or whatnot. Seeing the private players come into the space sector, what are we as space companies doing about the environment in general? I mean, recently Jeff Bezos and team did the space tour, and we all know about the carbon emission that had occurred due to that. I mean, space tourism could be a disaster for our planet's future, since it is not very equal way of sharing the planet's resources, isn't it? So are there any companies, or are there any policies or regulations, or even do we have companies that have lesser emission based rocket propellants that can be utilized? Are there studies done on that? Where are we at that stage in that aspect?
That is a great question. That is a great question. And recently, there is a YouTuber called Everyday Astronaut who did a full, complete video about the effect these rockets are causing in the environment. But the answer is, if you combine the entire rockets launched in a year and compare its carbon emission to a factory or like road transport, it would be less than 0.1%. Most of the rockets, they use hydrogen and oxygen. For example, even the Blue Origin's vehicle, it uses hydrogen and oxygen, and the output is just water vapor. So it is very safe. And recently, Blue Origin has also mentioned that in the webcast to say that their rockets are pretty environment friendly. So I don't think that rockets and space, mainly the rocket propulsion, is going to be a major concern for the environment. But the methodologies we use for manufacturing those components on the ground, maybe printing PCBs or manufacturing the aluminum, those would be a major concern than actual launch itself. Apart from that, even the major concern is the space debris, which would have serious troubles in the coming years than the amount of atmospheric pollutions caused by the rockets. That is going to be negligible when comparing to the other problems space industry is creating. And radio frequency and radio pollution is also another major thing. And companies are already running out of allotted frequencies. The spectrum is just getting out of hand.
Shankar and Sudhakar, do you have anything to add to that? Because this is something from everyone.
Yes, Safar, I have something to add to this. Like the first stage or the fourth stage of launch vehicles usually have solid propellants and the boosters,
right.
Where these solid propellants are aluminized, and we have ammonium perchlorate as the oxidizer, and this leaves hydrochloric acid in the atmosphere, and this is a major kind of pollutant. And if we see this cryogenic engines, we have liquid hydrogen and liquid oxygen. So that would be a viable solution, which can be a bit environment friendly. But typically, these cryogenic engines are used in the higher stages of the launch vehicles, either in the third or the fourth stage, due to safety concerns. Even if some hazard happens, it doesn't happen in a habitable zone. So another solution is we can go for hybrid rockets, where we can have low polluting and low carbon emission fuels, even polymers and the normal wax which we use for making candles. So that's a very economical alternative, and it can be used as a fuel.
Okay. Great. Thank you. We have one final question, and it's from Adarsh Pratap Singh. He asked, what do you think of the idea of CubeSat satellite having propulsion system in it? And then we launch our CubeSat without rocket.
Recently, we have propulsion systems developed for CubeSats, but see, these things are only for orbital maneuvers, like changing the orbit or controlling the orbit. The CubeSat itself cannot launch from ground to space because we need to reach orbital velocity. So you don't have enough delta V to reach. So,
All right. I think we're done with questions. I'll invite Lakshmi to give the vote of thanks.
I'm honored to be presenting the vote of thanks. Once again, a big thanks to everyone who had joined our session today. Thanks to the esteemed panel of speakers for sharing the knowledge, the topic, and for our moderator for having moderated the event fluidly. Special thanks to Hatchworks for being the ecosystem partner for the day. Hoping to see you all once again in another session in the future. Godspeed.
Thank you all. Thank you, guys. Thank you so much for joining. And I think we have some attendees from Sri Lanka. So there are some satellite initiatives happening here. We have Ravana 1 and Kidz India, which has been already launched. So there are some entities who are working on this. So do connect to SpaceNXT, as we are also trying to reach out to new frontiers here. And my personal thanks to all the speakers, Sudhakar, Shankar, Rifath as well, for sharing all your expertise today. And thank you, Lakshmi and Safar as well from the team. Definitely looking forward to another event very soon. Thank you all, guys.
Thank you.
Thank you all.
Thank you, guys. See you.
Thank you, guys.